So for number 3, we want to verify that the statement here is a tautology. So this statement is a conditional statement of the form if P then Q, and we have to remember that a conditional statement is true if P is false or Q is true. So if the antecedent is false or the consequent is true. So to show that this is a tautology, we have to show either that, let me highlight it, either that Q is true, and Q in this case is B, right? So we have to show either that B is true, or we have to show that P is false, or we have to show that this whole thing over here is false. So if we show either of these conditions, we actually have to show that these conditions always happen, right? That either B is going to be true or the antecedent is going to be false. Then if we show that, we have shown that it is a tautology. So let's look at the antecedent. We can see here that the antecedent is composed of a bunch of conjunctions, right? So it's going to be not B implies M, and not L, and not M or L. So it means that it's enough to show that any of these are false because of the conjunction, right? So if we have false and true, it's still going to output false. So our objective is to show that any of these are false. So let's begin with the proposition B, right? So B can have two possibilities. It can either be true or B can be false. So if B is true, then the consequent is true, right? So if B is true, that means that the whole conditional is going to be true, and so that works. But what if B is false? Well, if B is false, then we're in this situation over here, that not B implies M. So if B is false, not B is going to be true, right? So true implies M. This whole thing is only going to be false if M is false. So now we have to look at the truth value of M. So if M is false, we're going to have here not false, so true implies false, and that one's going to output false, and so our antecedent is false, and we have and the thing becomes a tautology. So if it's false, it works out. But what if M is true? What if M is true, right? What happens then? Well, if M is true, then we're going to get to this point here where we're going to have not M, so false, or L. So now if M is true, we have to worry about L. So this is going to lead us to L. And if L is false, then we're going to have here not true, so we're going to have false or false, and this whole thing is going to output false, and so the antecedent becomes false. So in this case, it checks out. But what if L is true? What if L is true? So if L is true, this thing is going to output true. However, now we get to not L. And if L is true, not L is going to output false. So either way, that is going to be false, and the antecedent is false, and the conditional is true. So we can see here in this kind of combination of truth values that no matter what the truth values of the propositions, it's always going to end up to a point where the either the consequent is true or either the antecedent is false, which I've marked with these yellow check marks. So we can see here that no matter the truth values of each of these propositions, the end result is always going to be a true conditional. So this is a tautology.